Welcome to Harrison Sec. Today, I'm going to show you a custom bootloader I wrote from scratch using a x86 assembly, a minimalist OS called a Sentinel OS. This bootloader starts with a simple password prompt. You get only 3 attempts. If all 3 fail, the system locks itself down for security reasons. Let's take a step back and look at what's really happening during boot. When a PC starts, the BIOS loads the first 512 bytes from the bootable drive into memory at address 0xS7C00 and then jumps to it. That's where our bootloader begins execution. These lines assemble 2 stages of our bootloader using NASM, stage 1.asm and stage 2.asm, compiled to flat binaries. We use DDD to write them directly into the boot sectors of a freed DOS image. The first stage of the bootloader, stage 1.asm, CKey is responsible for printing the welcome message and handing over control. It ends in an infinite loop to wait for stage 2. Inside the bootloader code, we rely on BIOS interrupt calls like INT TONH for low-level services, printing to screen, reading keyboard input, or halting the system on lockout. These interrupts reference the BIOS interrupt vector table, a lookup table located at memory address 0000:0000. Debug commands here allow us each entry in this table points to a BIOS service routine. When we call INT 10H, it jumps to the handler for video services. That's how we're able to display characters without any OS or library. We store the password validation logic entirely in assembly, checking input and limiting attempts. The form of programming: direct memory, direct BIOS services, no runtime, no safety net, just you and the metal. If you enjoyed this project, don't forget to like, share, and subscribe. Source code and build instructions are linked in the description. See you in the next one, where we dive deeper into OS internals and system security.